Okay guys, in this video I just want to take a quick look at how we can use our calculator to evaluate exponential functions at given x values. And so let's just really quickly recall what we mean by an exponential function is any function of the form y equals, and in your notes I wrote a to the x. I'm going to write b to the x here just to indicate that b is the base of our exponent here. And that exponent, of course, contains our x. So it is exponential because our x is in the exponent. But all these functions here can be written in this form, or just at least a modified form of something that's exponential. What we want to do is basically plug in some x values, get some y values back. So you think this would be a really easy task. As a matter of fact, it is pretty easy, but we're going to run into some situations where you just want to be careful with parentheses. So really quickly here, just taking a look at, say, number one, f of x equals 0.9 to the x. We just want to find f of 1.4. So in a tabular fashion, we would be saying that what we're plugging in is 1.4. What we want to know is what is 0.9 to the 1.4 power. And so in order to get this value back here, we're just going to put it in the calculator. And it's going to be really helpful that we can table values in this section. So we would say that what I end up with is 0.9, 0.9 to the power of, and I suppose we put it to the 1.4. So this is pretty easy. When we got to about 3 decimal places, so about 0.863-ish. So we get approximately 0.863, and that's what we'll be looking for right there. So it is as simple as plug and chug. That's all I want to do is go plug these values in. So let's take a look at a couple of other ones here that involve a little bit more in terms of parentheses. So say number 4, we have f of x equals this base 2/3 to the power of 5 times x, and what we want to do is plug in 3 over 10 for our x value here. So first things first, I'm going to write out f of 3/10 here, which would really be 2/3, okay, and this would be to the power of 5 times, and in parentheses here we could put 3/10. So here's the difficult thing about this. We have to put this into our calculator. It's not that hard to click buttons, but we do need to make sure that we use an appropriate amount of parentheses here. So first things first, we want to raise all of the 2/3 to this power. So we're going to put 2/3 in parentheses. We're also going to say to the power of 5 times, and I'm also going to put my 3/10 in parentheses because we're taking it times the 3 divided by 10 there. So I need to end parentheses, but we say 2/3 to the power of all of this right here. We get about 0.544. So this is approximately 0.544 as a function value. And then just for the last one here, I want to take a look at, say, number 6. We say f of 24. This would mean, of course, everywhere I see an x, we'll go plug in a 24. But we get 200 times 1.2 to the power of 12 times, in this case, 24. And so, yes, plug and chug again. But again, with the parentheses, we want to make sure that we're accurate here. So we would get 200, 200. Just put in parentheses your base, 1.2. And what we'll do is we'll raise that to the power here. Your calculator already knows, okay, that the base is only the 1.2. So when we hit enter here, we get about 1.274 and then e to the 25 here. So I'm going to put about 1.274 and then e to the 25. What I'd rather really write is this, times 10 to the 25. So one thing I want to make sure that I mention here is this. When you use your graphing calculator, or any calculator, when you see this e, it indicates that the number is either very, very, very large or very, very, very small, depending upon whether your exponent's positive or negative. But this really is scientific notation saying that it's really this number 1.274174348 if you move the decimal 25 times to the right. This would be acceptable right here. So know how to put these in your calculator, know how to use parentheses correctly. Cheers.